Okay, just really quickly, this is the last of the 3 videos for now regarding the t-test. So then, now that I gave you the 2 formulas, one for the pool t-test and the other one for the pair t-test, probably wondering how do I use it in statistics, because statistics, they give you this long paragraph, right? Sometimes they don't give you the column, like in this exercise 2.25, no column. So how do you do it? Well, you have to interpret it into words. So you see this sentence, right? We can read this. Even if you can't read it, you can see the sigma 1 equals sigma 2 equal 1.0 psi. So in here, what you can read this as is equal variance. And equal variance was the assumption for the pool t-test. Right? So when you have the pool t-test assumption up and you're finding the mean difference, specifically for estimating this confidence interval, then we know that when we're building a test statistic, which will give us ingredients like the MSE, and the actual random variable, which would be x1 bar minus x2 bar, that would just mean that this will require us pooling the variance, so the sample pooled variance for a t-test statistic. And this will require the degrees of freedom to be n1 plus n2 minus 2, because it's n1 minus 1, which is 9, plus n2 minus 1, which is 11, and that's 20, which is the same thing as 22 minus 2, also 20. And just to pay attention, the alpha used is 0.01, which is different because a lot of times we see alpha 0.05. Well, hey, this example is also 0.01 on the left-hand side of the page that I'm pointing to. So it's just something to know. And so that's one example right here, a hard example, something where you can't directly see the columns of the data, but you just have to trust the assumption they give you. And it's not directly stated that the population variances are equal. You have to already have that in your mind. This may just be some arbitrary thing in your head, and you may do a regular 2-sample t-test and get a different test statistic. It may still reject the null, or fail to reject the null, as if you use the pooled t-test, but it's risky because it's a different number. Let me know if maybe you want me to actually do this example by hand. Now for 2.26, conveniently, as they're next to each other, this example here from part A, it's saying test hypothesis that the 2 variances are equal using alpha 0.05, familiar significance level, right? So the 2 variances are equal. That's the equivalent of reading sigma 1 equals sigma 2. So reading is important. You have to know what these two can be back and forth, with the interchange between the two, right? Now, looking at exercise 2.26, the following are the burning times of the chemical flows of 2 different formulations. The design engineers are interested in both the mean and variance of the burning times. So, this is also pooled. You may think why? Why is it pooled? Because they didn't specify. Because first we know for paired, we can do proof by contradiction here. For paired, we know one good case is the situation has to have one column displaying like a time of the year 1950, and the other column displaying the second time that has passed, 1952. This setting does not qualify as that, and it doesn't qualify as twins. And what we infer here is type 1 and type 2 don't mean an independent I mean, they don't mean a dependent underlying relation going on. There's two different locations, and they both happen to have a building town. So if we were to make like a tree, these two would be rooted in two different areas. You can think of the two columns, these two big columns, as two separate trees. Then they're not going to be intertwined. Okay, so that's how you think of it. So they're both pulled. I can try to find another example that will be not pulled, something hopefully that's like paired. Well, this is definitely going to be pulled. Those are two different machines. Alright, so we know that. If it was from the same machine, the machine was doing two things simultaneously, then I'd get that. Or machine arm 1, machine arm 2 of the same machine, and then they're corresponding exactly, that's one thing. Because one thing you have to be careful of is sometimes it may be machine 1 on the left hand side and machine 2 on the right hand side, but the actual observations are intertwined, and they're not going to be corresponding exactly. So that's basically it.